Are you analyzing data where several individuals, firms, regions, or countries are observed over multiple periods? Then you are probably working with panel data. Panel data combine two dimensions, I, which represents the individual, country, company, or region, and T, which represents time. We therefore speak of data of the type YIT, XIT, where YIT is the dependent variable and XIT represents the explanatory variables. The great interest of panel data is that they allow us to study both the differences between individuals and the evolutions over time. Let's start with the general panel data model. The basic form is YIT equals beta 0 plus beta 1 x1 IT plus, and so on, plus MUI plus epsilon IT. In this equation, YIT is the dependent variable. The X's are the explanatory variables, MUI is the unobserved individual effect, and epsilon IT is the error term. The MUI effect is crucial. It captures the specific characteristics of each individual that are not directly observed, such as culture, institutional quality, or management style. First model, the pooled OLS model or stacked model. Here we assume that all observations can be grouped together as in a classic regression. This model ignores specific individual effects. The pooled OLS model is simple, but it can be biased if these unobserved differences influence the dependent variable. Second model, the fixed effects model, noted FE. It allows controlling for all individual characteristics that do not change over time. The within transformation eliminates the fixed individual effect. It is particularly useful when individual effects are correlated with the explanatory variables. Third model, the random effects model, noted RE. In this case, the individual effect is considered a random component of the total error term. If the assumption of no correlation is met, the random effects model can be more efficient than the fixed effects model. Otherwise, the estimators may be biased. The between model focuses on individual means, while the first difference method eliminates the fixed effect by subtracting the previous period's observations. Let's move on to the tests. The Fisher test allows us to know if the fixed individual effects are significant compared to the pooled OLS model. The Breusch-Pagan LM test for random effects compares the pooled model to the random effects model to detect the presence of individual random effects. The Hausman test is one of the most important. It allows choosing between fixed effects and random effects based on the correlation of the errors. Statistical models for social sciences consultant. Training today the skills that will make the difference tomorrow. After choosing the model, we must check for econometric problems. Autocorrelation appears when errors are correlated over time. The Wooldridge test is the standard reference. Heteroskedasticity means the variance of the errors is not constant. The common solution is to use robust standard errors to obtain reliable results. Cross-sectional dependence occurs when the errors of one individual are correlated with another. Specific corrections like Driscoll-Crye errors are then required. The complete workflow follows 10 key steps, from estimating the models to performing diagnostic tests and applying the necessary corrections. In summary, pooled OLS assumes no major differences, fixed effects control for constant traits, and random effects treat them as random error components. Subscribe for more practical content on statistics and econometrics. Statistical models for social sciences consultant, training today, the skills for tomorrow.